And we come to our last but not least speaker. And we have two speakers at the end, both from Microamp. Maybe let me start with that. So Microamp is a Polish company, is that true? Yes. That provides 5G solutions with a focus also on millimeter wave, if I see this correctly. You also have your own Genome B and you produce RUs that are also being used with the OpenAirInterface. There's also a demo to be seen later. Okay, I will correct. And I have here with me Sandrine Legrand, who is VP of Global Sales, and Andrea Forte, Head of Pre-Sales. And yes, they will now talk about extending the 5G, 6G use cases with millimeter wave. Thank you. This and
thanks. Thank you for the nice introduction. So very happy to be here and to actually close all the presentations today and of the workshop. And also very happy to present because it resonates, our presentation resonates very well with the one that Rob Sony gave when he started the workshop. What do we need as a network to support the AI revolution? What we see, of course, this is very similar to what Rob presented. We know that with the AI revolution, we need now networks that can do and support real-time data processing, very heavy data uplink, and add to that a lot of security. I think that the examples that Rob shared, the robotaxis, are very meaningful, and we know the strain that is going to be put on the wireless networks. So we think that 5G, 6G millimeter wave networks are a part of the answer, maybe not all the answer, but a good part of the answer. And what I want to share with you today is the directions that we are taking at Microamp to try to address the challenges that we see for wireless networks. The problem, and especially for the next-gen private networks, is really that right now we don't have the wireless technology yet that can solve all the issues that we are going to bump into. So all the closed systems are probably not flexible enough, not the ones that are needed by the industry. Sub-6 is really hitting right now the capacity limits, especially on uplinks. Millimeter wave is struggling as well with different spectrum, with the fragmentation, the fact that it's a little bit not yet customizable enough to support all the requirements that the factory is putting on networks, and that we cannot ask the factories to update and change their network every time they have a new requirements or a new capacity that they need to put on the network. So a part of the solution is what we are actually working on. What we're trying to develop right now is an NEG wireless platform, which is still totally optimized for today's 5G, 6G millimeter wave requirements. But we want to push that a little bit further. We want to have a platform that is totally reconfigurable, that is really a software-defined radio, and Genome B, because we do both. But that will be able to support different frequencies, so really from FR3 to sub-terahertz, right, while we are really now only on 24 to 29 gigahertz. We wanted to be able to support different network configuration, different standards even. So that's really the direction that we are taking, really trying to provide a solution that will support the very high performance that are required from wireless network, and making it as flexible as possible so that it can absorb all the new demands that are going to be put on the network. And with this, which is a bit futuristic and the direction that we are taking, I'll hand over to Andrea that will show what we have today, what we are working on right now, what are the use cases that we are already working on with some of you here, and then share, of course, what we see.
Thank you very much. In fact, I like, after a lot of these presentations about models and about things to look at and the platform that we are working on, I actually like to go over to the current product and how we use it. I'm still on this slide because I wanted you to pay attention that our NEG solution looks very much like our current product, and this is not a chance. Actually, you're going to see later on that our current product is this one, so our Cellbox RU, featuring a 7:2 split at the moment, and already providing carrier-grade, reliable performance. And this used in the fields. You see in all the FR2 bands, which are defined worldwide. So this is the outdoor version. Currently, we are proving to support 800 megahertz bandwidth, so two-layer MIMO with 800 megahertz, but the limitation actually is coming more from the CUDU side. The hardware of the RU can do much more, and therefore we'll see also this is coming along. Current ERP is 62 dBm of our active panel. Also, we are working to extend this because we see not only from a bandwidth expansion, but also from a use case, we see more power along coming. Requirements are coming. Still is a nice small backpack, so roughly 5 kilograms. You can see it in the demo room, which is there, at least from the old enclosure. So one topic which I would like here to use a couple of slides, a final slide, just to show more, since we integrated our AU also with OAI, how we can use it, how actually people as we speak are using it, which is quite interesting. One topic is obviously also, especially Isaac, that will cover the next slide, but here we already have one indication. So it's 1 gigahertz ready. Actually, the bandwidth supported is more than 1 gigahertz. So currently, as I was saying, the 800 megahertz bandwidth is a limitation from the server. We're getting more and more challenging having a server with a classical 3-sector, 2 layers, 800 megahertz each. It's getting quite powerful, quite specific server. We feature a fairly easy customization of beams. So we have our active antenna system, antenna panel, which is a 16 times 8 panel, element panel, and we are able obviously to customize it quite rapidly, I would say, in the sense that depending on the needs that you have, specifically it comes with a default setting with 256 beams covering 120 degrees sector, but in some cases you might want to have less beam, maybe more concentrated, more overlapping, and this we can do fairly easily while delivering the hardware. The platform itself is an FPGA-based platform, so you can use it especially for non-3GPP scenarios where you want to have a transmitting platform in that band, also with non-3GPP signals. Simply preloading them, and then you can fire. One clear example of that, we have in fact partners working in the research area with both with these multiple Isaac configurations. So here we show the monostatic and the bistatic configuration that you see, but it's also hinted in the lower part when looking at the band, especially here. Here we just put the 2 carriers that we support both the in-band and out-of-band configuration, and as I said, you can use it still as a monostatic, as a multistatic scenario. Quite interesting. We provide the capability of streaming live the IQ samples as well. This is, especially in this scenario, quite often used. Obviously, this cannot be done on the same server, on the same RAN server, because of performance issue. So in FR2, we have very often this challenge of simply getting the layer 1 data flowing fast enough. The other interesting scenario that we demonstrated, because by the way, we were demonstrating this at the ESA booth in Barcelona at the Mobile World Congress, is the NTN configuration, so that we were actually taking an FR2 cell simply, and then with the RAN server backhauling it via satellite. So this is working quite nicely. The fact that we can have then the same hardware again, also for the NTN link. We are currently working on the regenerative payload because this is a feature that it's coming along. Last but not least, I would also like to show such a scenario. I think more recently there are a lot of interest around drones. So the capability of one step back. Sandrine was mentioning about the technology and the difference with FR1. Interestingly enough, in FR2, you see there are no capacity issue, there are essentially no strong limitation in the sense of also the coverage that we are providing is something like 10 kilometers, where we are committing at least with line of sight. We are still looking for a test area to go beyond that, but as you probably remember, even 3GPP allows you to go more than 20 kilometers, at least from a RACH perspective. So having here such a scenario where you have a drone, it fits very well to our setup, because you're going to have a fiber-like, so a high bandwidth, high uplink in this case, because you're looking to have likely a non-compressed high-definition video stream from the drone, but you want to have also low latency. In fact, there was mentioned on some slide before, typically 5 milliseconds and below ping round trip time, so extremely fast, so allowing you to have drones connectivity. We were able to demonstrate as well the AAB feature, so where you can chain a couple of ops of cells, which would allow you to extend even the range of such equipment. As was mentioned before, Microamp is doing RAN. We do, with partner, offer an end-to-end solution as well. That's why you see also a picture of a USB dongle next to the drone, which is labeled Microamp. It's not our product, but we sell it as part of the end-to-end solution. And this is obviously a very nice fit on the drone itself, because it's light and fits to that scenario. So the message, I guess, clearly here is that among several studies, we do have a practical field-proven FR2 solution that you can apply in all the scenarios that we see in these 2 days and beyond, and that you can go out of the lab in the field today. Thank you very much. Not sure if there are any questions for Sandrine or myself.
So, you said the dongle, so it's you could say more about that?
So, let's say this way, due to the strategic decisions of a well-known equipment vendor, there is no smartphone in FR2, unfortunately, because from a cellular business there are some challenges in strategy there, although hardware would support it. So normally we operate with CPEs, which are boxes that size, 200 grams, and then we work also with the equipment provider which provides a dongle. The upper part is actually the panel antenna, so the lower part is this part here is more the processing part, and out of that you can continue with either with an Ethernet cable, with a Wi-Fi hotspot, or even a USB-C connection. So it's something really small, something like this, 100 grams, something like this. So facing, obviously you do have power, so we had also, I was talking before about A and B, we had also the scenario where we placed the RU directly on the drone just to eliminate an area. In that case, we had then the USB dongle on the vehicle moving around, so to say, in that area. But quite flexible solution, quite interesting, because then it really provides significant benefit. But we are pushing hard also to get more devices, especially with, I heard this also before, the devices capability are not as far as our requirements.
Okay.
Thank you very much again.
Thank you.